So FRQ number 3, part A, S is to draw the free body diagram of all the forces acting on the object when referring to this object right here. So I'm gonna draw the tube. Object is right here. We have a tension acting like that, so we'll call this T2. Also have tension acting this way. Call this, let's move it up here, T1. We have an FG. And then I'm gonna split up the T1s and T2s into components. This is gonna be your T2Y. This is gonna be your T2X. This is gonna be your T1Y. It's gonna be your T1X. We also have an FC acting towards the middle, causing this rotation. And then what I'm gonna do is I'm gonna label this thetas. At these points, they both are the same thetas because they're the same triangle, basically. These are 2 meters in hypotenuse, and then these have the same length in the legs right here as well. Total is gonna be your 3 meters. However, right here, this leg is gonna be 1.5 meters. This leg is gonna be 1.5 meters. Okay. Next, it asks us to find the tension of the upper string, so T1. First, I'm just gonna look at all the forces acting vertically, because it's easy like that, because I know that vertically the object is not accelerating, it's 0, it's constant, it has a constant vertical position. So we know that we'll label AY is 0 meters per second squared. So all the forces acting in the y direction is going to be T1y going up minus T2y, and then FG going down is 0. So I know that this theta right here is going to be T1 cosine theta. It's going to produce me the T1y minus T2 cosine theta. It's going to produce me the T2y minus mg equals 0. Now time to figure out the thetas. So since they're the same triangle, I'll just look at one triangle. Like this. Your theta right here. We know your hypotenuse is 2 meters. And then we know this leg right here is 1.5 meters. So easy enough, it's going to be theta equals cosine inverse of 1.5 meters. For 2 meters, it's just trig. So when you plug that into your calculator, you get 41.41 degrees, like that. What I'm also going to do right now is just going to figure out the length of this leg right here. I'm going to call it R, because this is the radius right here. So since we have the 41.41 degrees, would just be R equals 2 meters sine 41.41 degrees. That's going to give you your R. It's also just basic trig. Your R length is going to be 1.323 meters. So since we know the values for theta right now, I'm going to just factor out the cosine theta. So it's T1 minus T2. It's going to be cosine theta. And I added the mg over like that. So T1 minus T2 equals mg divided by cosine theta. Plug in the values. It's going to be 4 kilograms, 9.8 meters per second squared, over cosine 41.41 degrees. That's going to give you a value of 52.267 newtons. So now I'm just going to look in the x direction as well. The force acting in x direction is your FC. And then your FC is going to be composed of your combination of T1x and your T2x. So So t1x plus t2x. It's going to give you FC. FC is mv squared over r. Like that. So I know your t1x is going to be t1 sine theta plus t2 sine theta equals mv squared over r. What I'm going to do is factor it out. So it's t1 plus t2, and then multiply by sine theta equals mv squared over r. I'm going to divide the sine theta. So t1 plus t2 equals mv squared over r sine theta. Time to plug in the numbers. So t1 plus t2 equals 4 kilograms, 6 meters per second, and then square it. They tell us that the object rotates in a horizontal circle at a constant speed of 6 meters per second. Divided by r. We found your r right here. It's going to be 1.323 meters. And times it by sine 41.41 degrees. Finally, that calculation is going to give you 164.571 newtons. So right now, I'm just going to be figuring out what T2 is, isolating for T2. T2 equals 164.571 newtons minus T1. Using this, I can just plug in T2 back into right here, this equation right here. So it's going to be T1 minus, use this as a substitution, 164.571 newtons minus T1 equals 52.267 newtons, like that. And then what I'm going to do, we now know that it's 2T2. You add over the 164.571 over to the 52.267. It's going to give you 216.838 newtons. Oh, sorry, this is T1, not T2. There you go. Giving you a T1 of, when you divide 2, 108.419 newtons. Part C, it asks us to find the tension of the lower string. So T2, using the equation, we know that T2 equals 164.571 newtons minus T1. We know now that T1 is 108.419 newtons. Just plug into your calculator. That gives you 56.152 newtons. That's your T2. Like that. Next, for part D, that's us to find the angular velocity omega of the object. We know that V equals R omega. So V over R equals omega. We know that it's 6 meters per second divided by your R, which is 1.323 meters. Plug that into your calculator, it gives you 4.536 rads per second. That E asks us how much time would it take for the object to complete 10 revs. So what I'm gonna do is theta equals omega t plus 1/2 alpha t squared. Since the velocity is constant, that means the omega is also constant, meaning that there's no alpha. Alpha is 0 rads per second squared. So we know that theta equals omega t. Theta is going to be 10 revs, so it's 10 times 2 pi rads, because each rev is 2 pi rads, equals your omega, which is 4.536 rads per second. T, you divide the omega over to here. T would equal 13.853 seconds. That your F asks us to calculate the frequency F of the object. F is going to be equal to 1 over T. T stands for period. And then we know that period is 1 rev over omega. So it's 2 pi rad over your omega, giving us 1.385 seconds. So it takes us 1.385 seconds for the object to complete 1 revolution. So just plug in your t value now, 1.385 seconds, and that's gonna give you 0.722 seconds to the -1. There you go. Thank you.